Those Space People is a podcast series of casual cosmic conversations with people working on exciting space projects. Today we have Christian Williges, who is a new space consultant based in Berlin, Germany. He had co-founded the new space company Constellar and had previously worked with the German Aerospace Center DLR, and he also has a background in laser and opto technologies. Welcome to the show, Christian. Thanks for joining us.
Rachna, thank you very much for having me, especially on this very day. It's 1st of January 2021, so a splendid way to start a new year, to be your guest on a podcast. And I have to admit, it's the very first podcast that I am invited to, so thank you very much for the opportunity.
Can you tell us a little bit about your background, about your time at DLR, and then what led you to founding Constellar?
So my background, I really have to reach out quite long in time. I was always interested in photography, so this was already as a teenager. It was one of my hobbies, and so I started an apprenticeship. Like really, I think it was around the year 2000, so like 20 years ago, in a high-end photo laboratory back in Düsseldorf in North Rhine-Westphalia. So I worked there for quite some years, but at the end I realized, okay, maybe there is more about this photography thing that I could achieve. So I decided to really go to university. So after I already worked, I went to university. And as you already mentioned, I studied laser and opto technologies in the University of Jena, so Ernst Abbe University. This was quite a time. I mean, on the one hand, it was quite a decision to move to Jena because it's on the other side of the country. Yeah, so I moved really to the eastern part of Germany. A lot of my friends said, "Okay, what are you going to do there? There's basically nothing." And I said, "No, it's not nothing there. In Jena, they invented optics. So if I want to study optics, I should go there." And I never regretted this decision. It was really a fantastic time that I had there. So the university it is rather small, or let's say the field of studies is rather small. The department we've been we started with 50 people. And all very nerdy, and everyone was into laser and stuff like this. So this was really a cool time. And after 6 years, I thought, okay, I had some research projects here and there, and I thought, okay, I'm not only interested in photography, but also in not only in imagery, but also in space. So let's see where I can combine these two fields of interest of mine. So I did some research and realized that in Berlin, where I live actually right now, there is the Institute of Optical Sensor Systems from German Aerospace Center. And I sent an application if I could my master thesis do there. And it was on a random Wednesday evening, like, I don't know, maybe 8:30 or something like this. And like 5 minutes later, I received an answer from my then future boss who said, "Oh yeah, that's cool. I read your application. It looks very nice. Can we have a phone call?" And I said, "Oh, this is too quick. This was too fast." Okay. I didn't expect such a quick reaction. And I said, okay, maybe 2 days so that I have some kind of preparation. And basically that was the start of my space career. A prompt reply from my future boss. And I don't know, maybe a couple of weeks later, I've been in Berlin and started my master thesis. It was about high resolution satellite cameras and the autonomous refocusing mechanism that I spent my first year on. And right afterwards, I was hired at DLR and I started basically as an optical engineer, and developed over actually very quickly into some kind of management position. So first starting with AIT management, so assembly integration testing, for the DESIS project. DESIS is quite an interesting project. It's a collaboration between Teledyne Brown Engineering from the US and the German Aerospace Center. It's a hyperspectral instrument that is now attached to the ISS. So its purpose is Earth observation for a variety of applications. So this is, I started there also as an optical engineer. I was responsible on the one hand for the spectrometer, on the other hand for the filters that were needed. And then I also developed myself into the AIT manager. And this was basically the start when I realized, okay, this management stuff is quite something for me. I liked it much more than being in the laboratory, I have to admit. I know there are not too many guys who say this, but really it's more the organizational part of the work that catches me. So then, yeah, quite quickly, my boss realized that I'm doing a good job there on the management side. And this was also the time when Airbus approached DLR if they could run the verification campaign, so the radiometric verification campaign for the Sentinel-4 focal plane subsystem at DLR. So because we at DLR we have the laboratory space for it, we have the illumination sources for it, etc., etc. So the thermal vacuum chambers and all these testing stuff. So we had the capabilities from a laboratory point of view, but he was missing a project manager, and he asked me, okay, do you think you could do it? And I said, wow, that's a big opportunity. Okay, of course I want to do it. So I mean, just imagine, I was feeling very fresh. I think it was maybe my third or fourth year at DLR, and to be assigned to such a project, to really work for the Copernicus program of the European Union was really something. Wow. So I was so proud that he asked me, and of course I took the job. I took the opportunity. Yeah, this was really my first assignment as a project manager. It went quite well. So we met the objectives in time, and we delivered on time. And we had a very successful test campaign. And yeah, so then the next thing rang the bell. So it was for the Korean Aerospace Research Institute, KARI. It was that they wanted to develop the next camera for their COMSAT-7 satellite. And so our institute has quite a long heritage with KARI. So we already developed the focal plane system for the COMSAT-3 satellite. That's a high resolution satellite in the more or less in the visual range with like a 50 centimeter resolution. And so now they want it for the next generation, for the COMSAT-7. And so my boss again approached me and said, okay, again, we are missing a project manager. What about you? And I said, okay, that's the thing. Of course, I'm going to do it. Yeah, so this was really the biggest project at this moment that the Institute ever had. Also for me, of course, the biggest project that I could ever lead. And this was really quite an adventure because now I had a team of like more than 20 engineers from different departments with different backgrounds, like from electronics, mechanics, software. This was really quite something to juggle all these different types of tasks, of personalities, of backgrounds, etc., etc. But it was quite good. I mean, it helped me to develop, to get a feeling of what is needed, what is important, on how to steer a project through all these uncertainties that you have during a development project. This was quite good. Yeah, so this was basically how I entered DLR and what I did there.
So did you have any project management training during your time as a project manager, or did you just pick up the ropes as you went?
I mean, DLR they are a big institution, so they have a very advanced training program for like their employees. So whatever you're interested in, basically. So from what field ever you are, like from engineering or from project management or from controlling or whatever, they have specific training programs that you can attend to really develop yourself in a professional way. And of course, this is something that I did because I thought, okay, this is absolutely mandatory to do so. But it was also a lot of learning along the road. Yeah, because whatever you learn in a theoretical course, I had the impression you can just put it into the bin like after like 2 days in a real life in a project because nothing goes as planned. So there's really a lot of learning along the road. It's nothing beats the personal experience that you have. Yeah. So really it was a combination of both. Yeah, the theoretical background, but also learning by doing.
So then, was it your entrepreneurial spirit, rather should I say your managerial spirit, that led you to form Constellar, or how did that start about?
How did it start about? This is also quite an interesting story. It started, I think it was the year 2016, maybe. Let's pretend it was the year 2016, when I attended a seminar for space optics from ESA. Yeah, so it's a 1-week seminar on Sardinia. And I can really recommend the seminar. I don't know exactly the name, but if you Google ESA Space Optics seminar, something like this, then you will find it. It is extremely good. ESA did a great job in really picking the right people, talking about very, very different aspects of space optics. So I asked my boss back in this time, okay, this is quite an interesting seminar. Could I please attend it? Thankfully, he said he approved it, and so I went to Sardinia, and this is where I met Max Gulde, also one of the co-founders of Constellar. And we had quite some time there. So it was, I mean, on the one hand, it was the professional seminars that we could attend. This was quite interesting, but also we really developed a very good personal relationship. And also after the seminar was over and we went back, he's from Freiburg, so in the completely different part of Germany, in the very, very southwest of Germany, where I lived in the northeast of Germany. Whenever we've been somehow close to each other, we just met for an hour or something and shared a pizza and just talked about our ongoing project and so on. And it was like maybe 2018. Yeah, it must have been mid of 2018, so a little bit more than 2 years ago. When he basically called me and said, okay, I have this interesting idea. So my institute is going. So he's working at Fraunhofer EMI in Freiburg, and he said my institute is going into this new space sector, so and wants to develop or is already developing CubeSats. And so DLR, my Institute of Optical Sensor Systems, was more into this classic space domain. So these large institutional satellite components that really cost a couple of $1 million or euros. And he said, okay, maybe we should try to bring our institutes together. Yeah, to really develop something new. So his idea was basically to bring the thermal infrared on a small CubeSat, what did not have happened before. So we tried a couple of months to bring our institutes together, but as you can imagine, institutes are sometimes very slow. I don't want to complain about institutional life, yeah. It was if you really have this drive that you think, okay, guys, that's so slow. And then so one day he said, okay, come on, let's just do it by ourselves. And this was the moment when we really started to work on this idea of Constellar. Back then it was not called Constellar but Thermi, so Thermi. quite a cute name that we quickly agreed to, that we have to change it because it was just too cute for a market. So then, so he already had a colleague at his Fraunhofer Institute, Marius. He was also on board, and then during one of the, as they are from Fraunhofer, Fraunhofer has a very, very advanced program for like spin-offs. Yeah, let's say for spin-offs or for startups. It's called Fraunhofer Venture, so the department, and they have the AHEAD program. And so this is during the AHEAD program, we've been assigned to one business development guy, so Chris, and he was also very, very fascinated by our idea, and it took him like, I think maybe 30 seconds to decide that he wanted to be on board. Maybe not even 30 seconds, maybe 3 nanoseconds or something like this. This was basically the moment when we've been the team of 4, and then for the next months and years, we tremendously worked on this idea of like putting a thermal infrared CubeSat constellation into a low Earth orbit, to monitor our planet. Yeah, so this all started as a side project of our, let's say, real work of our full-time jobs at DLR at Fraunhofer. Yeah, we've been quite successful with this. We gained a grant from Bundeswirtschaftsministerium, so Ministry of Economics. Yeah.
So what's Constellar doing now?
We've been quite successful in gaining grant. The grant helps us, or helps Constellar to bring its demonstrator into a low Earth orbit. It won't be on a dedicated satellite, or it will be on a dedicated satellite, but it's a satellite that already exists. It's the ISS, the International Space Station, that we will use. So the camera will be attached, or the payload will be attached to the ISS. It will serve as a demonstrator for the whole process of taking images, pre-processing it, sending it down to Earth, post-process it here, and provide it to users. So this will be the first step, of building the constellation, and then afterward, with the help of venture capital and the usual financial aspects that you have in such a startup, the constellation will with the demonstrator as, let's say, as one of the cornerstones of it.
How do you make a business case out of these kind of projects? Monitoring or resource mapping? Who are the stakeholders? Who would want to invest in you?
That's really something. How do you make a business business out of it. Talking to people. Really, it's the only way. I mean, it's really. You can read it in books, and it's really the way it is. You form a hypothesis. What will be your customers, or what will be your use case, and then you're searching for the right people who could be your customers, and then you validate or invalidate your hypothesis. For Constellar, it was invalidation of our first hypothesis, because we thought, okay, with a thermal infrared camera, so the technology allows for very high accuracy and also for very high ground resolution. But it also makes the satellite a little bit larger than usual, and hence also more costly. So our first approach was to really go into the fire detection market, because it was already in these times when we had these annual wildfires in California, in Australia, etc., in Siberia. And so this seemed to be a very, very big thing. And we thought, okay, there must be a good market for it. And so we talked to all these people who might be interested, I don't know, reinsurance companies, and we tried to approach governments, etc. And we realized, okay, there is somehow a mismatch between the market that we thought there would be and our technical and financial constraints that we would have with our technology. So we realized, okay, somehow it doesn't really fit. I think it was again Max who came up with the idea, or he recognized that in agriculture, thermal infrared imagery can really be a boost for like gaining higher yields and really having a more resilient and productive agriculture. Yeah. So, and then this was when we pivoted. Yeah, that's something that you usually do in a startup, just pivoting. We actually thought about naming us the pivot company. we just changed our business idea quite often. So, but at the end, agriculture was the main market that we realized would be it. To give you an impression what thermal infrared doing there, let's say with the common Earth observation systems that you have that mostly operate in the visual range, yeah, you can assess the actual state of crops. Yeah, you can say, okay, I look down and we have maybe, I don't know, we have June, so the crop should be green, and I look at it with my satellite, and yes, it is green. So everything seems to be fine. Or you can say, okay, no, it's not green anymore, it's yellowish. Then you know, okay, something went wrong, and but then it's usually too late to really react. So to have any countermeasures. So, but thermal infrared imagery allows you to somehow have a glimpse into the future of crop health. So that means when you assess the temperature of a plant, you can compare it to the temperature that it should have during or according to the conditions there, for weather, for the time in the year, for the status of plant itself. If there is a discrepancy between the actual measured temperature and the temperature it should have, then you know, okay, something is going wrong there. So maybe the plant doesn't have enough water, or there's a pest or a disease or whatever. But this is state when the plant still appears to be green. So from a visual point of view, you would say, okay, everything's fine. But from the thermal infrared, from the temperature point of view, you see, okay, there's something going on. So there's something wrong. And you can investigate on it, and you can take appropriate countermeasures that save the plant. So it doesn't go wasted, but you really can save it. You can water it, you can have some fungicides or pesticides on it to really save it. And this at the end will help to increase the yield. And this is something where we thought, okay, I mean, in like only 30 years, there will be like 2-3 billion more people living on this planet. So we are facing like having like 9 billion people in the year 2050 living on Earth. So they need food, they need to be fed. With our current technology, it seems to be quite hard to really have these higher yields. So because you cannot put just much more fertilizer on the field. So it's basically at the end. And what we need to do is to come up with a new technology to really increase the yields and to do something for the health of the plants. So we realized, okay, that's the technology that could do this. And we talked to stakeholders from companies that are already in this field. We talked to people from academia who are doing research in it, and everyone was like, wow, you're going to bring up a thermal infrared constellation. That's exactly the thing that we need. And then we thought, okay, that's it. Let's focus on the agriculture market, and that's where we ended up. I mean, there are some side markets, but agriculture will be the main market.
Is the instrument of Constellar to be up on ISS?
It's planned to be on the ISS by end of this year, so end of 2021. Then we will have the assessment of if everything works as expected. Then afterwards, like in the next years, the constellation will be built up.
What form factor is the constellation right now? Because initially you wanted to put it on a satellite, but what is now the form factor?
It's planned to be 16U.
Recently, you've been involved with the Golden Records. Can you tell us more about this?
It's a holding company for as long as I was participating in Constellar. And the golden records, it's a nerdy joke somehow. The golden records refers to the 2 golden records that are attached to the 2 Voyager probes by NASA 40 years ago or something like this, and that left our solar system 2, 3, 4 years ago, something like this. I thought this would just be a good name for a small holding company, because just like the original golden records, they just contain a variety of impressions of human life, of Earth, of whatever life on Earth can be. So like rain and bird songs and songs from different cultures, etc., etc. So then I thought, okay, I also have quite a variety in my background, so why not naming my company like this?
Oh, that's very smart.
It's a nerdy joke. Thanks for calling it smart. Thank you.
So what do you do with the golden records?
Originally, it was only intended to be the holding company for Constellar from my side. So, but now that I dropped out of Constellar, so just at the moment, I'm just taking some time off with the family. I do some consulting for also for remote sensing startup, where I can just boost them a little bit with my expertise that I gained during the last 2 years at Constellar, because they're not doing to do the same, but let's say the field is close enough. I mean, remote sensing is always more or less the same. Not really, but close enough. So I can just boost them a little bit and then guide them into the right direction. I left Constellar in November 2020 due to family reasons. Maybe to explain this a little bit, just for the last 2 years, I mean, I had quite a tremendous workload. Having my job at DLR, trying to scale up a startup in the new space industry that's really going to run. I had 60, 70 hours per week as a workload. Then in 2020, the pandemic on top was just a little bit too much. So I decided to stop it here, to decide for my family. We have 2 little kids. They really miss their father. And so this is something, I don't know where the golden records are going. I would definitely stay in the new space industry, and not sure. So at this very moment, I'm really focusing on family life. My family, they really did a lot for me in the last 2 years to really make my dream come true. Now it's really time to give back, and it's really nice to see my little son, my 3-year-old son, how happy he reacts, and when we are playing and everything. So this is
family.
What the Golden Records is doing at the moment, taking care of the family.
Yeah, family is certainly very important, especially for someone building a company. It's also nice that you are trying to help companies through the golden records in your spare time. There are already a lot of remote sensing companies, right? And I'm talking about the upstream. So if you look at the upstream, we already have, for example, Planet, who's taking care of the optical. And then we have recently Capella Space, who, took over the SAR completely. And then now we're going to have Constellar soon to take over the IR space. So is there any more space left for people to come in? Where is innovation further needed? Where is further disruption needed?
I think there is still space left. Oh, pun intended. Oh, pun unintended. I mean, just in the visual range. I mean, you could go into higher ground resolution. Yeah, like Maxar is doing with its, how's it called, with its Legion satellites. Yeah, so I think they're aiming for 30 centimeter ground resolution with a tasking satellite. You could go in finer spectral resolution. I think there is Cosine. I think it's the startup is called Cosine, who are going to develop, or who already developed, the hyperspectral instrument for a CubeSat. In the visual range, there is quite some space. And of course, I think what we see currently with the internet satellites, this will also happen with Earth observation satellites. Yeah, that every country or every region really wants to have its own satellites, so that they, in times of emergency, that they really can rely on their own infrastructure. I think this is something that we will see. To make this big split, what is obvious is China, they will most probably not buy any Earth observation imagery from a US company, but they will just build their own satellite infrastructure. And most probably the same will be for the European Union and maybe for Australia. I heard that Canada, they also have their small satellite constellation that is really monitoring only Canada. So there's still a lot of space left. So this on the one hand for the upstream industry, and I mean the same will be for the downstream industry. Because if you have all these providers of imagery, there will always be a niche where some clever guys will see, okay, if I take images from this satellite and from this satellite and combine it, then I can serve a specific market. So I think there will be a lot of small companies serving on a B2B basis, will serve some other companies with their insights that they can gain from remote sensing.
We have a lot of these companies going the full stack way, right? For example, Planet is building the satellites, operating them, also selling the products, processing the imagery, and so on and so forth. So you still think that these small companies, the clever companies, will still have a way to survive?
I think so, yeah, because companies like Planet or Maxar, they cannot do it all. In my opinion, it doesn't make sense for them to really go into each and every niche. It's like at the end, they will be big companies and it will be just too high organizational workload to go for this. While maybe a startup of like 2-3 persons, basically no overhead because they are operating from their garage, maybe, yeah, they can just serve these niches on a lower cost base. That's why I think there will be a lot of these small companies. And maybe at the end, they will grow bigger because they see, okay, from the one niche, we can widen up a little bit more and transfer our model to another region. I think a good example is Live.io from Berlin. They started 3-4 years ago with 2-3-4 people, something like this, and restarted to serve Deutsche Bahn. It was a small niche that made absolute sense to serve with the Earth observation imagery. Now they're expanding to the US and they grew like tremendously over the last few years. I think there will be quite some startups that can go the same way.
How does someone get a job in this industry? What skill sets do you think they need? And secondly, if someone wants to create something in space, like have a remote sensing company or remote sensing satellite company, the upstream or the downstream, what skill set do you think someone might need?
Maybe to answer the second question first, there's this guy, Jeffrey Manber, the founder and CEO of Nanorex, quite a big company. For example, they started business on the ISS to deploy satellites, CubeSats from the ISS. They started the first 20, 40, 50, I don't know, satellites from Planet from the ISS. They also have this Bishop airlock and on the ISS for like experiments and stuff like this. So the founder, from his background, he has nothing to do with engineering or space industry or whatsoever. I think he was something like a reporter or something. What he had or still has is just quite a network of people, because during writing his stories, he of course reached out to all these people who had something to say in the space industry. So he just had a very, very big network. And then he realized, okay, if I just combine the dots, I can be the guy in the middle who really makes a business out of it. So, and that's when he created Nanorex. I think that's more or less the story, how it started. So to answer the question, what do you need to really create a company in the space industry? Maybe just a very, very huge network and some brilliant ideas how to combine the dots. Yeah. So this could help. I think maybe at the end, you really don't need a degree in engineering or whatsoever, but just a bold idea and people who really help you to make it come reality. So this on the one end, but of course, if you look at Elon Musk, I think he's quite a genius when it comes also to engineering. So it might help if you have some clue about the engineering stuff. So, and I mean, your first question, how do you get to this space work at all? I mean, it really helps to come from the engineering side so that you really know what you're doing there, what the hardware is, what the software does, so that you just know what you're building there. So because most of the business that we are talking about is at the end based on hardware. I mean, the space hardware. I mean, there's now a lot of software companies. An engineering degree in either some hardware development or software development would absolutely help. And then I think there are just a lot of ways how to enter this. You could either, just like me, apply for a thesis at DLR. I know quite some people who did it. Your last guest on your podcast, Agnieszka, she's doing her PhD also at the German Aerospace Center.
Yes.
So that's of course one way to enter. But I mean, you could also just, if you're a decent programmer, just knock at the door of Live.io and say, okay, guys, you're doing cool stuff. I would like to help you. And then, booms, just like that, you're also working for a software company in the space industry. So I think it was in no point in time before, it was easier to do something with space. So I think we're living in a fantastic time. Basically, everyone who would be interested could do something with space technology.
What is the best way for people to contact you, be it either space enthusiasts or budding space professionals or budding entrepreneurs?
I'd say really LinkedIn. LinkedIn is my number one source of information. That really helped me also getting started with Constellar, because you could easily reach out to people, see who's in their contact list and so on a regular basis, like 2-3 times a day. I'm on LinkedIn, checking the news, checking what's going on. If someone's going to reach me, then LinkedIn would be the choice.
Thank you, Christian. It was a great conversation. Thank you very much for coming on the show.
Yeah, Rachna, thank you very much for inviting me. It was really a pleasure. As I said, splendid way to start a new year. I would really like to wish you all the best with your podcast, with your professional life, with your personal life in the next year, and also in the days after.